Hello students, so let's try to solve one very beautiful problem from IE Irodov, and this is a problem from the mechanics but mainly a special theory of relativity. So this is a wonderful problem, straightforward but very conceptual, and you have to do very smart calculation. This is the most important thing. So what is given? So it is given that a particle of rest mass m naught moving along the x-axis in some frame k according to this particular law. So what is this law? That is function between position and time, and this is given as your x is equal to, so this is given as x is equal to root under a square c square t square. So this is your position is given, and where a and c are constant, obviously c is the speed of light, and what we have to do, we have to calculate what is force acting on a particle. This is very wonderful problem. So how we will calculate force, and this equation is given that how x and t is going to vary. So we have to just see how we can calculate the force. So what is the idea behind? So when we have to calculate the force, we have to go for the Newton's law. That is the basic concept we have to do. So what is Newton's law? The Newton's law we can write is nothing dp upon dt. This is nothing but force. So this is basically equation of motion. This is second law, rate of change of momentum is force. But if we will see this particular momentum in a very careful manner, then this momentum is not m naught v, rather it is m naught v root under 1 minus v square c square. So students, you have to always take care of this type of expression. So for the relativistic momentum, so relativistic momentum P is defined as mv, and this m must be relativistic in mass. So that value is equal to m naught v root under 1 minus v square c square, because relativistic mass and the relationship between relativistic mass and rest mass is given as m is equal to m naught root under 1 minus v square upon c square. So this is the main thing we have to do. So if somehow we can calculate this particular value, because x versus t is given, then we can easily write what is the value of v, and somehow we can calculate this value and we will differentiate with respect to t, then obviously we will get the answer. So let's try to solve this problem in a very nice way. So what is given? So it is given that x is equal to nothing but root under a square plus c square t square. So we know x dot is nothing but velocity, and that value is equal to c square t. We have to differentiate completely. So this will be c square t and root under a square plus c square t square. So ये हम जब differentiate करेंगे तो इसे हमें मिल जाएगा. So once we will get this one, but we have to be very much careful that we have to find this value actually, this value. M naught v root under 1 minus v square c square. And now we have to just go for, so let's try to first calculate what will be 1 minus v square upon c square. So here we can write v upon c is nothing but ct, we can divide c from here. Ct, this is root under a square plus c square t square, root under this one. And we have v square upon c square is equal to c square t square root under a square plus c square t square and whole square. And from there we can get v square upon c square is equal to c square t square and a square plus c square t square. And what we have to do? We have to calculate 1 minus v square upon c square, and that value is 1 minus c square t square upon a square c square t square. And when we will go for this one, we will get this value is actually a square upon a square plus c square t square. But we have to find the value of root under this one. So from there, we can get root under 1 minus v square c square is equal to a upon root under a square plus c square t square. So from here, we can get this one. So let's come to the next level. We have to actually calculate v upon this particular value because we have to write what is the expression of momentum actually. So let us try to go for next page. So when we are going to this one, so what we have? We have basically 1 minus v square c square root under is equal to a root under a square plus c square t square. And what is the value of v? The value of v is given ct root under a square plus c square t square. And what is value of momentum? The value of momentum is m naught v upon root under 1 minus v square c square. And then we can go for this one m naught, and this value is equal to ct and upon a square c square t square, and we have to write 1 upon this one. So this value is equal to root under a square c square t square upon a, and these two things will cancel out, and this value is basically, so this value is m naught and this value is c square actually, this will be c square. So this is m naught c square t. So this p is equal to m naught c square t upon a. So this is your momentum actually. So once you will find the momentum, then obviously what will be rate of change of momentum, and this is nothing but the relativistic momentum. So this is very interesting. This is nothing but what? Relativistic momentum. So this is my value of momentum, and we know what is the force. The law of nature will always remain same. So that value is dp upon dt, and from there we can get m naught c square, and we can easily differentiate this one. So that value is equal to d upon dt, and that value is m naught c square t upon a. When we will differentiate with respect to time, so force is nothing m naught c square upon a. And you can see this force is independent of time, that is constant force. And very interestingly, this m naught c square is nothing but the rest mass. So it may be in some examination, they can ask you this force in form of rest mass. So that will be rest mass energy by A. So this is m naught c square is nothing but what? Rest mass energy. So students, look at how beautiful this problem is. So one equation is given, and from that equation we can easily find the momentum. So we can easily find the momentum, and once we will find the momentum, then obviously we can go for what is our value of force with this particular equation of motion, and we can easily calculate it. And in a reverse way, what you can see, you can also see one of the very fundamental things. This is very interesting. This is very interesting. If your force is constant, then your x is basically in this form, a square c square t square. Your x is something like in this form. And if you will see the thing between x versus t, then you have x square minus c square t square is equal to a square, which is nothing but rectangular hyperbola. And if you will remember this particular thing for a Newtonian mechanics, if your force is constant, then x versus t is parabolic. So this is very interesting. For x versus t is parabolic. X versus t is parabolic in a Galilean transformation, but you will see x versus t is hyperbolic in a Lorentz transformation if your force is constant. Force is constant. So this is very interesting. For the constant force, we have x is equal to ut plus half a t square kind of thing. And here you have x square minus c square t square is equal to a square. So this is a wonderful problem, very insightful problem. And you can easily use Newton's law in a relativistic form if you will have a clear-cut concept of relativistic momentum, relativistic mass, and relativistic energy. Thank you.